So this video is the third assignment on about the gate questions related to the sensor. So based on the search I have done in GATE 2016, there is no question directly related to Arduino water flow sensor, but the concepts are used like the Hall effect and fluid mechanics. So here are some relevant questions that I would like to talk about. So the question on Hall effect was the water flow sensor you asked about. Uses Hall effect sensor to detect the rotation of magnetized rotor. So the GATE 2016 question included questions the test of understanding of this very principle. So the first question, force in Hall effect transducers topic. This question directly addresses the fundamental physics behind the sensor. It asks about the force exerted by a magnetic field on moving charges, the charge carriers inside the Hall effect transducer. So the question, force exerted by the magnetic field in Hall effect transducers is, so there were four options: Lorentz, Hall effect, magnetic and electric. So the correct answer is Lorentz force. And the explanation, the Lorentz force F is equals to Q E plus V into B is the fundamental force experienced by a charged particle moving in the magnetic field. The force is what causes the charge carriers to deflect, creating the Hall voltage, while the result is the Hall effect. The underlying force is correctly termed the Lorentz force. Here Q is the charge, E is the like, B is the magnetic force, buoyant force something. About the second question, parameters measured by Hall effect. So the topic was around the question, test the knowledge of what information can be obtained by performing Hall effect measurement. So this is crucial for the understanding the capabilities and limitations of the sensor. Which of the following parameters can be found with Hall effect? A, B, C, D, polarity, conductivity, carrier, and area of the device. So the answer is area of the device. The Hall effect is used to determine the type of charge carriers, polarity, N type or P type, their concentration, and the material's conductivity and mobility. So the physical dimensions of the device, such as its area, do not affect the high Hall voltage and cannot be determined from its measurement. And and also there was a question fluid mechanics fundamentals. So beyond the electronic sensing principle, measuring flow involves the physics of fluid movement. So question from GATE 2016, shift 3. So the question was laminar flow in a pipe. Topic, this question deals with the velocity profile and shear stress in a fully developed steady laminar flow with within a circular pipe, a classic fluid mechanics problem. So the question was, consider a fully developed steady laminar flow of an incompressible fluid with viscosity mu through a circular pipe of radius r, given the velocity at a radial location of r by 2 from the center line of the pipe is u1 and the shear stress of the wall is k mu into u1 upon r, where k is. So the calculated value for k is 2.667. Explanation. So this is numerical problem where you must apply the formula. So it was formula based question. And in GATE 2016, only this question was there. They were not directly related to the sensor. But in other GATE exams like GATE 2015, there was about the venturi meter, a question on calculating maximum height of a venturi from a reservoir using Bernoulli's equation and continuity equation. In also in 2015 about parallel pipe systems. So a question on the correct expression of total flow rate and frictional head loss in the three parallel pipes. In 2020 about the flow in inclined pipes. A question on calculating head loss due to friction in an inclined pipe of uniform diameter. And in GATE 2020 last, flow through a nozzle. A question on calculating pressure difference in the nozzle flow assuming steady incompressible and in viscid flow. So understanding the four GATE question. So GATE question are designed rather than understanding on the fluid dynamics, thermodynamics, concept based, rather than just the how the sensor work. About on what concept does the sensor work? That is main in the GATE exam. When flow measurement is covered, the questions are typically about standard device like venturi meters, orifice meters, and pitot pipes, sorry, tubes. So these are analyzed through fluid mechanics equations to determine flow rate based on the pressure differences, not by using electronic sensors like YFS201. So this was about the GATE questions. Uh, so what is the conclusion overall of the past two assignment? So water flow sensors have evolved from ancient measurement techniques through industrial instrumentation to become accessible components for anyone with an Arduino. So the combination of Hall effect sensing, affordable manufacturing, and the open source maker movement has democratized flow measurement technology that was once the domain of specialized engineers. These sensors enable countless applications that address real world needs, preventing devastating water damage, conserving precious resources, automating tedious tasks, providing data for informed decision making. From the simple digital flow meter suitable for beginners' first project, complex IoT enabled multi zone irrigation controllers. So, as water scarcity becomes an increasingly urgent global challenge, technologies that help us monitor, understand, and conserve water will only grow in importance. The humble water flow sensor, paired with accessibility of Arduino, puts the capability in the hands of students, hobbyists, and innovators worldwide, empowering a new generation to develop solutions for a water conscious future. So, whether you are building a system to protect your home or flooding, optimizing, so this sensor can be used, and with the information, we can build like applications like multi-water, water quality and flow sensor, also in agriculture domain, etc. So, this is it for now. Thank you.